me to record. So what is this access control is all about?
Alpha.
Please mute yourself.
Welcome back.
So majorly what we use access list for is to enforce some network security policy. Why cameras briefly? Is it this class? Yeah, in OSPF. And then guidelines for creating access list. Then the types of IP version 4 access lists. Can you people hear me? You can type if you can hear me. Okay, thank you.
Yes.
All right, so let's talk about the purpose of access list. Basically, it's for network security policy. You know, some people, they look at this like a firewall. Not a dedicated firewall, just a form of firewall, more or less like you're turning your router to a firewall to filter traffic. You know, firewall is more of filtering traffic, what you allow, what you permit, what you allow, and so on and so forth. So basically, that's what we want to also do with our router. In case I don't want to go and buy a dedicated firewall, I want to still be able to do some form of firewall on my network. I can use the same router that is doing routing to also do some level of firewall. So what is an ACL? What is an ACL? An access control list is a series of iOS commands that are used to filter packets based on information found in the packet header. It's a series of commands, operating system, that is Internet Operating System commands that are used to filter packets based on information found in the packet. And I'm going to explain that to you guys more. By default, a router does not have any access control list configured. By default, your router does not have access list configured. When an ACL is applied to an interface, that is when we configure the access list, the router performs the additional task of evaluating all network packets as they pass through the interface to determine if the packet can be forwarded. So another way to define this access list is this. An access control list uses a sequential list of permits or deny statements. Sequential list of permit, that means line of commands following themselves, and we're going to see some of them. That will be in next class, known as access control entries. So when we talk about access list, you're going to hear us talking about ACE. The entries that we have created is referred to as ACE, or group of entries that we have created, or group of access list statement is what we refer to as ACE. So let me give you an example. You know, I like to give you background, so it helps some people to flow better if they have a background. Let's assume we have a router and we have a LAN connection here. Let's say call LAN A, let's say LAN B, and let's say we have internet connection. We can configure access control list on this router to block everybody on this LAN from going to the internet. And we say we want to allow them to talk to this LAN A. Or we can say these people on this in LAN A should be able to go to the internet, but they shouldn't talk to people in LAN B for whatever reason. We can use access list to make this decision. So we create statement of deny or statement of permit. And you're going to see the examples when we come to configuration. So access list, create a statement of deny or statement of permit. So it depends on the policies you want to implement. Who are the people you want to block? What are the things you want to block them for? Now, we're going to come to a level where you will see that this as our access list, which is also a form of firewall, is limited compared to the firewalls that we have nowadays, the dedicated firewall. This is limited, but it can still allow us to do some level of stuff. Okay, so watch out. When network traffic passes through an interface configured with an ACL, the routers compares the information within the packet against the ACE in sequential order to determine if the packet matches one of the ACE, and this process is called packet filtering. So what we are simply saying is this: if a router has an ACL configured and applied on an interface, by the time packets are entering that interface, the router will be checking. It's like you have a party, and you have decided that the people that will enter that party environment are the people that will wear black or only on red. So you put people at the door, or what do you call those people? Bodyguard or whatever, like security agent. Answer to go to be checking. Are you wearing red? Are you wearing red? Are you wearing red? Are you wearing red? If we have made a statement and we have agreed that we make a policy that the people that can enter the club or that can enter that party, they are the only people on red. So the security people will allow only the people on red, and they will deny the people that are on other colors. So what the router basically does is, if you check the list of the statement, what did we tell the router to do? Block a particular IP address, block a particular network, block some people from going to where? Are they being blocked from going to Facebook? Or can they go to Facebook and not go to Yahoo? Or can they go to Yahoo and not go to Facebook? What time of the day can they browse the internet? You can create what we call time-based access list, where you decide that you can browse now, you can browse later. You can browse, like in some banks, you realize that within office period, they cannot browse the internet. Not only banks, some organization, they can't browse the internet. That is if they don't have if their job is not internet based. But once it is break time, they will automatically be able to browse. That is because access control list has been configured on their router to give them access to the internet at that point in time. So it's a statement that will help you to make, or statement of permit or deny, that will help you to make some decision. And what the router will keep on doing is filtering packets based on the sequential statement or list of statements of permit or deny. So these are different tasks that the router will perform when the router has access list, or different reason why we create access list. Why do you create access list? Why would you want to create access list on the network? To limit network traffic, to increase network performance. You can reduce the rate at which people browse. For instance, now, even though this is limited, maybe people go to YouTube a lot in your organization, and you want to try to filter YouTube, not because you want to block YouTube completely, but you can limit the bandwidth they use for YouTube. You can say, okay, out of the 10 meg you have for the organization, people can only use 1 meg. So all the people that want to go to YouTube, they will be using 1 meg to go to YouTube, even though this ACL is not capable of doing that. But I'm just giving you an example. So you can try to make some decision, block some traffic, then prioritize some traffic. For instance, in the universities, you know that people will always go to Google because they need to do research. People will always send mail, maybe Gmail and all of that. Some people will also go to YouTube to do one or two things. So you can decide to prioritize Google, prioritize Gmail, prioritize all the website that the school need for that academic purposes. And these are some of the things that we can do with our firewall. Let me not just say access list. Access is limited. That is when we want to configure on the router. It's limited, and you're going to see why it's limited. So we can provide traffic flow control. You decide where traffic comes from, where it goes to. You provide a basic level of security for network access. I've just explained that. You can filter traffic based on traffic type. You can say you don't want anybody to be able to download on your network. You block FTP. Complete download, and nobody will be able to download. Anything that has to do with download, you don't want it on your network. You can even go as far as saying you want to block video. ACL may not be able to do that. Okay, people can go to Facebook, they cannot play video on Facebook. Maybe they can go to Yahoo, but they cannot play video if there are videos on that website. These are things that we use firewall to do. But the access list is just like a kindergarten state of firewall, setting up firewall. And for people that have never heard about firewall, firewall is just something that helps you to deny or permit traffic. You make decision. You can have it as a dedicated device. You can have it installed on machines, and you can also use your router to set up basic firewall feature. Basic firewall feature. Like for instance, now the baba of firewall. When I say the baba, that is the first stage of firewall is to block everybody from outside from coming into your network. So if you are connected to the internet now, you don't want to allow people to initiate traffic from outside, but people can initiate traffic from inside to outside, and then you allow the return traffic. Access list can do this for us. So you can decide to screen computer that is hosted on the network. You can permit them or deny them access to some services. It's almost the same thing we're saying. I can say, okay, I want people to be able to send email on my network, but they can't download. Or I want people to be able to send email, download, but they cannot go to a particular website. You can filter the website out. And you provide priority to certain classes of network traffic, just like what I've explained in this place, where you say, okay, if people are going to Yahoo, you can give bandwidth, you can allocate bandwidth to Google. Say, okay, you know, people go to Google a lot, you can allocate 5 meg to Google. So why are you doing that? Yes, I'm coming, Mr. Someone. Why are you doing that? You want to make sure that no matter the traffic congestion on the network, you want to make sure that Google has enough bandwidth for people to access Google. Other websites like Instagram, YouTube, or Facebook, you can just give one small bandwidth. So when people are struggling to go to those websites, they will just leave those websites alone. But during the peak period or office time, maybe around 4 o'clock, you can now increase the bandwidth for some of those websites. Let me read your question. Yes, ACL configuration on a router is the same thing as a router, using a router as a firewall. You are very correct. So we want to basically turn our router to a firewall, not doing the work of firewall completely, but it is also doing the job of firewall. Mr. Summer, are you flowing with me? Okay. So what we want to simply do is for people that don't really understand firewall, let me give you another example. A lot of people know about antivirus. What the antivirus basically does is to protect your system. So at that level, that is host level, host base. But when you talk about firewall, it is about network security, protecting the network from the router before the bad guys will come in. Let us try to implement some policies. Let us try to block some traffic. That is the essence of firewall. Am I communicating? Please talk to me, guys. We're not going to do configuration today. I don't have the energy today. My day was a bit busy in the office, so I will just do the explanation. Then on Wednesday, I'll come and do configuration. Okay. Now, look at the reason why our access list is limited. Access lists that we're talking about only operate at layer 3 and not layer 4. It cannot operate at layer 5, 6, up to 7. So, you want to block a website. Access list cannot block a website by domain name. What I mean by that, Let's say I want to block www.facebook.com. This is the domain name of Facebook. This domain name is about application layer. Access list cannot do that. If I know the IP address of Facebook, because access lists operate at layer 3, I can block the IP address of Facebook, but I can't block by domain name. And why is it difficult to block by IP address? Facebook alone, we have nothing less than 10 different IP addresses, different servers or more. And they are always hiding. Sometimes 20 servers all over in different countries all over the world. So when you block somebody by domain name, when you block a website by domain name, it doesn't matter the IP address you are coming with. You are blocked. But access controllers cannot do that. So this is why people go for dedicated firewall. Mr. Samuel, are you saying that? So our router is limited. So dedicated firewall can block by domain name, which is application here. That's why they call them next generation firewall. Next generation. They can do a lot of fantastic stuff. Like Cisco ASA, like Fortinet, like Palo Alto. Those are crazy firewall that can do a lot of stuff. You can say, okay, people can go to Facebook, decide the time they can go to Facebook, maybe from 4 to 6 or 12 to 1 during break. And even if they go to Facebook, they should not be able to play video. They can just read text, but they can't play video. Dedicated firewall can do all of those things, but your access list cannot do that. So why can't our access list do all of these things? Because access list only operates at layer 3 and layer 4. It can filter at layer 3, IP addresses. It can filter at layer 4, port numbers. So we're going to learn access list. We're going to see the configuration. We're going to see how far we can go. But in the real world, you have to go beyond this. You go for a dedicated firewall. Most companies, most organizations go for dedicated firewall. But we still have to learn the basics here. If we don't have a dedicated firewall, can we still do access list? Or can we still implement some policies on our network? Oh, yeah, we can do that. Okay, packet filtering. Packet filtering control access to a network by analyzing the incoming and the outgoing packets and forwarding them and discarding them based on given criteria. Who is going to define this criteria? You as the administrator. You decide the criteria you want the router to use to block or to allow people to go. Packet filtering can occur at layer 3 and layer 4. Packet filtering can occur at layer 3 and layer 4. And that is why I told you our access list is limited. You cannot just operate more. You can't operate at layer 7. You can only operate at layer 3 and 4. Just a minute, please. I need to plug my laptop. Okay. So Cisco routers support 2 types of ACL. We have standard ACL. We have extended ACL. These are the 2 different types of standard, access control list. Standard ACL and extended ACL. Standard ACL only filters at layer 3 using the source IPv4 address only. Take note of this. So when we are configuring, standard access list can only filter based on source IP address. Meaning what? I can block you by your IP address, but I cannot decide the destination. I cannot block you based on destination. What I'm simply trying to say is this: I cannot decide and say, when I block you by your IP address, I block you. It is not flexible. I can't say you can go to Facebook, but you can't go to Yahoo. Or you can go to Yahoo, you can't go to Instagram. These are different destinations. Our standard access list cannot do that. But for extended access list, it can filter based on source IP address, based on destination IP address, and can also filter based on protocol. I can say, I am allowing you to go to so destination, but you cannot go to this destination. And when you get to this destination, these are the things you can do at that destination. Those are the protocols. Like, okay, I can point to, you can have a remote login, you can download, you can have a browsing experience, and so on and so forth. So your extended access list filters at layer 3 using the source and destination IP address. They can also filter at layer 4 using TCP and UDP port number and optional protocol types information for final control. So what is the difference between standard access list and extended access list? Standard access list can only filter based on source IP address. That's it. But extended access list can filter based on source IP address, can filter, that's at layer 3 now, can filter like based on destination IP address, and can also filter at layer 4 using TCP or UDP. So when I tell you that access list operates at layer 3 and layer 4, I'm talking of standard at layer 3, and I'm talking of extended at both layer 3 and layer 4. And we're going to configure the two. You will see how we make use of standard, and you see how we make use of extended. When we need to block somebody, and we don't care where you're going to, we just want to block you from all destinations, we block you by standard IP address. But when we need to be flexible to say, okay, you can go to this, but don't go to that, or we block you from going to this, but you cannot go to that. Either way, we just want to be flexible. We have to go for extended access list, because extended access list has that flexibility, or you call it granularity. You can decide to say, go to Yahoo, don't go to Google. Go to Google, don't go to Yahoo. You can decide on destination where to go to. So that one is flexible. Exactly. Okay, thank you guys. Access control is operation. We have said some things about it. Now we're going to say another thing. Now, this part, you may not understand it but until we come to configuration, or you may not understand it better. Access control defines the set of rules that give added control for packets that enter, take note, inbound interfaces. Anytime you hear inbound interfaces, that means the packet is coming through that interface. And anytime you hear outbound interface, that means the packet is expected to go out from another side. So in this scenario right now, if this is me here sending, and I am sending message to Ali, the message will go through this router. This is the inbound interface. And then the message will go through the other side. This is the outbound. So when we are creating our access list, we have to decide the direction of the traffic. What do I mean by that? Do I want to tell the router, as this packet is coming in, check it and decide before it enters the router? Or as the packet is going out, check it as it's going out of the router. Make decision based on the given criteria. So that is what we mean by inbound ACL and outbound ACL. It depends on where we apply the access list, because we can create the statement and not apply it. And let me tell you this, if you create a statement, access list statement, and you forget to apply it, the access list will not work. If you create statements of permit or deny on your router and you do not apply it on an interface as inbound or as outbound, the access list is not going to work. So when you create an ACL, you must apply it on an interface as inbound ACL or as outbound ACL, and you're going to see the rule. How do we know when to apply it as inbound? How do we know when to apply it outbound? There are rules that needs to be followed. Access control can be configured to apply to inbound traffic or outbound traffic. That is what I just explained. So it depends on what you are trying to do, and it depends on the type of access list you've configured. Take note of this. This is important. ACL do not act on packets that originate from the router itself. If I enter this router now and I'm pinging from this router, even if you have tried to block ping on this interface, access is not going to catch up with that. Because the packet originated from the router, access list is not going to catch the packet. An inbound ACL filter packet before they are routed to the outbound interface. What does that mean? If you create your statement and you decide to apply it on this interface, that is referred to as inbound ACL. So decision will be made before that packet will come out from the other side. But if you create your statement and apply it on the interface here, the decision will be made before the packet is pushed out to the destination. So we have inbound ACL, we have outbound ACL. So this is what they said here. An inbound ACL is sufficient because it saves the overhead of routing lookup if the packet is discarded. What is the meaning of that? If you know you want to block a packet, why do you have to go and block it on this interface? Why not block the packet from here? Because if you don't block the packet or if you don't apply it on this interface, you go and apply it on this interface, you have given the router additional work. What the router should have blocked on this interface, make up his mind. The MAC packet will enter into the router. The router will route it out. See, you are supposed to go out from this interface. And by the time you now get to this interface, it will now be applying the access list statement and then now block it here. So you've wasted the router's resources. So if you are need to block, it is better you block from the source, closest to the source of the message. But there are situations where you cannot block closest to the source of the message. You have to go and block on the other side. It depends on the scenario. And then an outbound ACL, which is the one on the other side, filters packet after being routed because the router must have decided where to send the packet to, regardless of the inbound interface. So if you create your access list and you decide to apply it on the outbound interface, you have overworked your router. You've given the router extra work. Still talking about ACL operation. When an ACL is applied to an interface, it follows a specific operating procedures. Here are the operational steps used when traffic has entered a router interface with an inbound standard IPv4 ACL configure. So when you apply the ACL on a particular interface, maybe the inbound here. Now, let me tell you something here. If this is me here, this is Ali here. If I'm the one sending, this is inbound. This is outbound. If Ali is the one sending message, the difference is, the message is different because at that point in time, Ali becomes the source, I become the destination. This becomes inbound, and the other side becomes outbound. So it depends on where the packet is coming from. You need to be aware of that. So when we say inbound, it's relative. Where is the packet coming from? When we say outbound, it's relative. If the packet, that's where the packet will go out to get to the destination, then you are correct. But when the person is replying back or the person is they want to initiate a connection, that is going to change. So when you apply the access list on an interface, what happens? The router extracts the source IPv4 address from the packet header. We've talked about header under OSR model. It will go to check, okay, what's the IP address on this in this packet here? Then the router starts at the top of ACL because you can have more than one ACL, one line of statement, and compare the source IPv4 address to each ACE, that is the entry, in sequential order. What did they say I should do to this IP address? When a match is made, once the router discovers something like this about that IP address, bam, the router carries the instruction, either permitting or denying the packet, and the remaining ACL in the remaining ACs in the access list, if any, are not analyzed. Once the router has seen that, okay, out of 10 statements, I have seen that I should deny this particular IP address, it will not even bother doing anything again. It blocks that IP address. Other statements are ignored. If the source IP address does not match any ACE, that is access list entries, in the ACL, the packet is discarded. Why? Take note, we didn't say you should be blocked. The moment you configure an ACL on a router, something called implicit deny. What is implicit deny? Even if I do not intend to deny you, I have to explicitly tell my router that I am permitting you. If not, the router is going to block you. Take note of that phrase, implicit deny. Meaning you are all denied by default. The moment you put an ACL on a router and you don't come and tell the router, please permit everybody. I'm not intending to block anybody. I just want to filter some traffic here. Or you want to filter some people. Let's say now, in this class now, we have Ali, we have Mr. Samuel, we have Eniola. So let's assume that my intention is to block Ali and Mr. Samuel. I can write statement to block Ali by IP address, write statement, block Mr. Samuel, and then stop there. Do you know what my router will do? The router will also block Eniola. Once he sees deny, he will continue to deny everybody. I have to come down and tell the router, these are the only two people I want to deny. All other people should be allowed or permitted, or I have to explicitly say, permit Eniola to go. So implicit deny simply says, if I see deny first, I deny everything in my path. You have to come and inform the router that you don't intend to deny everybody. So that is implicit deny. We're going to see it at work when we do the configuration. So that is what they are also saying here. The last ACE statement of an ACL is always an implicit deny. What does it do? It blocks all traffic, and it is hidden, and it's not displaying the configuration. So if you are now wondering, but I block Mr. Sam, I didn't block Eniola. How come Eniola cannot go? Implicit deny has caught up with Eniola. I have to come to my router and tell the router, permit all other people, or just permit Eniola if I still intend to deny other people. Note, an ACL must have at least, look at it here, one permit statement. If the access list does not have one permit statement, what will the access list do? It will deny every other person because of implicit deny. Everybody will be denied, except the people that you are intending to deny two people. Everybody on that network will be denied because of implicit denial. So we must come down and say permit, we must create a permit statement. All right, any question on this before we proceed? Today is just story. Maybe 1 hour, 1.5 hours should be done. I don't have the energy. Okay, good. I don't have the energy to do the lab today, so I will do the lab on Wednesday. So people should try to enter class on time. Are we good? Can I proceed? Good. Okay. Now, I spoke about, Eniola, are you flowing with us? I didn't see your thumbs up or 777. Okay. I've not seen her. Eniola, are you still there?
Yes, sir.
Are you flowing?
Yes, sir.
Okay. So when we did OSPF, I spoke about wildcard mask. What is wildcard mask? Wildcard mask is the inverse of subnet mask. And funniest enough, we also use this wildcard mask in ACL. As a matter of fact, I like teaching ACL before teaching OSPF because we'll talk more about the wildcard mask inside access control list. So we want to talk about the wildcard mask again here. What is wildcard mask? Wildcard mask simply means inverse of subnet mask. So you need to understand the way access list treats or use this wildcard mask to match the IP address. So you need to follow me carefully now and see. A wildcard mask is similar to a subnet mask in that it uses the ANDing process to identify which bit in IPv4 address to match. Unlike a subnet mask, in which binary is equal to a match, Binary 1 is equal to a match. Take note of that. You know, if I wrote something like this, 192.168.100.0, and then I write 255.255.255.0. If you convert this 255 to binary, this is 11111234567 1234567 1234578. So this is what indicate that this is our network portion. That's how we use subnet mask. So a match, we're just telling you that this match, this match, this match, our network portion. But the way we use wildcard mask is not like that. So now, in subnet mask, binary 1 is equal to a match. Binary 0 just simply means anything can be here, we don't care. That is the meaning of 0. That is in our subnet mask. In a wildcard mask, the reverse is the true. The reverse is true in a wildcard mask. What does that mean? An IPv4 AC entry uses a 32-bit wildcard mask. What does that mean? To determine which bit of the address to examine for a match. So if I am creating access list now and I want to block this IP address, 192.168.100.10, my wildcard mask, what did they say? 32 bits will determine the bits to match. And what they are telling us here, the wildcard mask bit of 0 means what? It matches the corresponding bit value in the address. So if I want to put wildcard mask for this IP address right now, because I want to match this, match this, match this, match this, I'm going to say 0.0.0.0. This is a wildcard mask. So in access list, zeros means match, 1 means ignore. I repeat, 0 simply means match, 1 means ignore. So because I have zeros all through here, it simply means I care about this octet, 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 I care about all the 4 octets. So I'm pointing to a particular IP address. What if all I care about is the network portion? I can say something like this: 192.168.100.0. I just care about this network portion. I don't care about the other side. My wildcard mask is going to be 0.0.0.255. 0 simply means a match. I care about this octet. I care about this octet. I care about this octet. I don't bloody care about this octet. If I'm denying people with this network portion right now, it means anything can be here. This thing will catch up with the person. Like you are denying everybody in the network. Once I see 192.168.100 deny, or if I'm permitting everybody 192.168.100 permit. So 0 simply means a match. 0 wildcard match simply means a match, or 0 bit 0 means a match. Am I communicating? So when you want to match a host, like I said, I want to deny Harley, my wildcard mask will be zeros all through. But if I want to deny everybody on the network where Ali came from, my wildcard mask is going to be something like 0.0.0.255. I care about the network portion. I don't bloody care who is in the other portion. Anybody with this IP address, I am denying the person. That is how we use wildcard mask. The wildcard mask is the inverse of subnet mask. 0 means a match, and 1 means ignore. And when we say 1, we're talking of 255. Because if you convert 255 to binary, you get ones all through. Zero means ignore. Match. 1 means ignore. That is the way access list works. So look at the example here too. They gave us this IP address 192.168.1.1. We want to match this, match this, match this, match it. What is our wildcard mask? 0.0.0.0. So my router will factor in this, factor in this, factor in this, factor in this. And we use this when we want to just block a host or permit a host. 0 means a match, permits this IP address, and we put the wildcard mask, zeros all through. Look at another example here. I've given you this example already. I am particular about this octet. I want a match in this octet. I also want a match in this octet. So I am particular about these 3 octets. I don't care what is in the last octet. I don't bloody care. Once I have these 3, my policy is implemented. So I care about the network portion, not the host portion. And we do this when we want to block the whole network, everybody on the network, or you want to permit everybody on the network. It depends on the policy. And when I say permit, it could be permit to access a particular website or a particular application or a particular service. That is that on that one. Can I proceed? Yeah. Let me read your question, Mr. Roger. I have to tell you people that are consistent in this class, I truly, truly appreciate your commitment, honestly. Mr. Rogel is one of them. You're always, okay, you're apologizing for coming late. I didn't even know that that is what you wrote. You're always, always, always there. And I really, really appreciate. I'm thinking of how to further encourage you guys. Maybe when we're done with this class, I will be cracking my brain on what to do for you guys. I appreciate people like that. Because it's not easy, you just have to pay the price. No, you're welcome, no problem, sir. All right. Some other stuff to talk about here. Wide canvas keywords. Sometimes when we're creating what do you call it? Access list. You see us using some words, word like host, word like any. When do we use these words? The Cisco areas provide 2 keywords to identify most common use of wide can masking. The 2 keywords are host. When do we use this? You can use this word host to substitute for this 0.0.0.0 mask. So it simply means if I'm creating access list, this is how we create access list. In fact, let me go to the router and show you an example. Let me just go to the router, bring a router out. I hope you guys can see my screen. Now watch. I want to show you how to create access list. Conf global configuration one. I will say access lists. That's the command. Access list. Let me put question mark. Can you see that there is a range here? 1 to 199. That is when I want to create standard access list. So if I say access list 1, that means I'm creating standard access list. Access list 2, I'm creating standard. Access list 3. But the moment I jump to access list 100, I am creating extended access list. So they are designated by numbers. 1 to 99, it means 1 to 99 means standard access list. 100 to 199 means extended access list. Take note of that. So this is the idea. Let's assume I want to create standard now and say access list 1 permits 192.168.100.10. Let's say this is our list IP address 0.0.0.0. That means I want to permit Ali, and I have put his IP address, and then I put is the wide canvas for that IP address. What this means is I am particularly about the first octet, I am particularly about the second octet, I'm particularly about the third octet, and particularly about the fourth octet. If I hit enter right now, my router will take it. But what we are trying to tell you right now, if I don't want to use this 0.0.0.0, I can as well go to my router and say access list 1 permits host 192.168.100.10. This host word, this word host here, has replaced the 0.0.0.0. The router knows that we are referring to all the octets. Access list 1 permit host 192.168.100.10. This is a replacement for our wide canvas. We can use that word host. to just a computer, you can use that word host if you are referring to just a computer. I hope that is clear. That is one. So that is how you use the word host to replace wildcard mask when you are creating your access list. And sometimes you can use the word any to replace what? When you want to substitute for a wildcard mask of 255, 255, 255, 255. Ignore. This mask says ignore the entire IPv4 address or to accept any address. Now you're going to see the way I will make use of any later. I'm cracking my brain now. How can I make use of any for you guys? Let me try something and see. Access list 1. Access list 1 permits. No, let's say it's to ignore now. It can't be permits now. This is not going to be a good example. I will use that one for you under extended. Let me get one. No, let me not go there. Let's take that sample. Let's just take note of that. When I come to the configuration, it's easier for me to use the example under extended to demonstrate this any for you guys. But just know that host is used to replace 0.0.0 and the any is used to replace 255.255.255.255. And this simply means ignore the entire IP address or to accept any IP address outside of this. It's better used for me under extended. Take note. So the guidelines for creating access control list. What are the guidelines for creating access control list? You must have a reason why you want to create access list. What are the things you want to block? Who are the people you want to block? Are you blocking the whole network? Are you blocking some set of people on the network? Are you blocking one or two? Just all those kind of stuff. But apart from that one, you need to be aware of these guidelines. Limited number of ACL per interface. That is one of the things you need to do. There is a limit on the number of ACL that can be applied on the interface. You can't just keep on creating access lane and be applying it. As a matter of fact, this was amazing. I saw it in when one for our CCNP training in South Africa. The guy was trying to show us that when you create too much access list, it will slow down the RAM of the router, even the CPU. So we loaded some ACL on the router just to prove that point. And it overwhelmed the router. Because don't forget, this router is also doing routing for us. It's doing is running routing stuff. He's doing NAT. We are going to do NAT maybe on Friday. I'm thinking we can meet on Friday so that we can wrap up this program on Friday or maybe on Monday. He's going to do a lot of stuff, and then you are now making it to work also as a firewall. That's why people do not overwhelm their router or go and disturb the router to do firewall. They have another device, which is going to be a dedicated firewall that is making all these policies. They are using to make all these policies. Other people to go out, people to come in, filter. More or less like you put antivirus in between your router and the internet. But it is beyond antivirus. I'm just using that one as an example. So you can create limited number of access lists that can be applied on a router interface. You can put for IPv4 if you want, and you can put for IP version 6. You can put one outbound, you can put one inbound for IPv4. What does that mean? Outbound, I've told you, it depends on it's relative. It depends on where the traffic is coming from. You can put one, you can implement one or apply one on this inbound interface, apply another one on the outbound interface. And you can do one for IPv4, outbound, one outbound for IPv4, one inbound for IPv4. The same thing can be done for IPv6. So what that means is, I've never tried this. It just occurred to me right now. What if I have like 10 different access lists? Access list 1, access list 2, access list 3, access list 4, access list 5, up to 10. Can I apply all of them on different interfaces? I doubt it. I've never tried that. Note, access control lists do not have to be configured in both directions. Once you grab it in one direction, inbound, you are good, or outbound, you are good. The number of ACLs and their direction applied to the interface will depend on the security policy of the organization. It all depends on what you are trying to achieve. Don't forget that. And this skill, you can, even me, the trainer, I don't know I see some access lists. I wonder, how did they create this access list? What are they trying to achieve? One day I stumbled at one of our service providers router in the university. I just was like, the person that created this access list must be a CCNA person. I studied the access list, I understood what it's doing, but I would not have been able to create the access list all by myself to do all of those stuff. So the point I'm making is, when I'm done with this class, the configuration is on Wednesday, and give you labs to do, and you do the lab successfully, don't think that is the end of access list. There are some complex access lists at CCNP level, complex access lists at CCIE level. But at least you are going to learn the foundation in this class. So, ACL best practices. What are the best practices recommended? Using ACL require attention to details, take notes, and great case. Mistakes can be costly in terms of downtime. You can bring down the whole network. One statement like this can shut down the whole network if you don't understand what you are doing. Then troubleshooting effort, and then you can have poor network services because you're overwhelming the router CPU. Basic planning is required before configuring an ACL. You must plan it out. What do? Guidelines. Base ACL on the organizational security policy. What do they really need? Write out what you want the ACL to do. What kind of problem are you trying to solve? Make sure that you will not create another problem for you. You can use a text editor to create it, and then you can document the ACL using Remark. I'm going to show you how to also use Remark. Then test the access control list. The access control list on a development network before implementing them on a production network, especially when people have closed for work. Run it, test it, make sure there is no problem, and in case you run into trouble, you quickly reverse back. Those are the guidelines. Be aware of these guidelines. So the types of ACL, I've showed you standard, I've showed you extended. This can only filter or deny or permit based on source, only source. This one can filter based on source IP address, destination IP address, source and destination TCP or UDP. That's what I told you, that extended is flexible. You can do way more than standard access list. And sometimes you have to go for extended. It depends on what you are trying to achieve. Look at it here. Access list, the question mark. You can see 1 to 99 is standard. 100 to 199 is extended. But they have others here that I don't have in my packet tracer. You can see we have another range of numbers that points to standard. 1,300 to 1,999 is also standard. And then we have 2,000 to 2,699 is also extended. So these are ranges, but the one that we use most of the time, they are between the range of 1 to 99 and 100 to 199. You can also see them in this place. These are a standard access list, and the other ones are extended access list. Once you pick a number from that range, that determines the type of access list you are trying to configure, and the router knows immediately. So look at another example here. The third one, why don't we call this one a separate as type of access list? Because this could be name standard, name extended. What does that mean? Instead of using number, we decided to use a name. So we can create our standard access list and give it a name. We can create a extended access list and give it a name. And all of this we are going to do in our next class. Look at what they did in this list. IP access list extended. That means we are creating extended access list. And look at the name they gave. FTP filter is filtering FTP. So when you hear name access list, it's not as if it's another type of access list or the third type of access list. No, we're just saying we have a name ACL, and that name ACL could be standard and it could be extended. Either of the two. It could be standard, it could be extended. So we're going to create our standard access list by number. We'll create extended access list by number, and then later on, we create either of the two or both of them by name. Those ones are called named access list. Remember, I said when you create access list, you must apply the access list on an interface. Any access list created and not applied on an interface is as good as if you didn't create the access. It's not going to work. When you create access lists, you must apply the access list. Sorry, let me get rid of this taskbar. It's blocking my stuff here. Okay, so when you create access list, you must apply the access list on an interface. You create the access list at global configuration mode, but you must apply it on an interface. That is what they are trying to tell you here. How do you know where to place an access list? Every access list should be placed where it has the greatest impact on efficiency. There is a rule for a standard access list. Look at the rule. It should be located as close as possible to the source of the traffic to be filtered. So if I am trying to filter this computer now, let's say this is Ali, I don't want him to go out through this interface. And I have decided to create extended access list. I can filter him from here. I can filter him from here. But the rule says when I create extended access list, I should filter him from the interface that is closest to the source. From between these two interfaces, which of them is closer to the source? G0/0/0 is closer to Ali. So I will go and implement my access list on this interface. It doesn't mean that if I put it here, it will not work. I can filter him on this interface too, but I have put extra work on my router. So extended access lists are usually placed near the source. This is the source interface. If I'm filtering this person now, I will put this here. So that is why when you know you want to filter people like this, it makes sense for you to create extended access list so you don't overwhelm the router. Because if you create standard, look at the rule of the standard. Standard access list should be located as close to the destination as possible. So let's assume I am filtering Ali from talking to Mr. Samuel here. Look at where Mr. Samuel is. I have access to router 1. I don't have access to router 2. I don't have access to router 3. And I've created standard access list. Where will I put the access list? The rule says I should put it on the interface that's closest to the destination. Between this interface and this other interface, this one here is closer to the destination because see Mr. Samuel here, he is the destination. See Ali here, Ali is the source. So I will apply the, what do you call it? The access list on this interface. But the best thing to have done in this scenario, if I have access to this router, it makes sense for me to create the access list on this router. Since I want to use standard access list and place it here because this is the interface that is the closest to destination. So if you don't have access to this router, you have access to this router, you put it here. What if you have access to this router, you put it on this interface? So when you are creating a standard access list, follow the rule. When you're creating standard, follow the rule. I've never tried to break the rule and invert where to place it and see if it will work. I've never tried that, or you can try that. When we are done with the lab, it just occurred to me now. You can try that. So, but the rule says you create extended places or apply it closest to the interface, the source that is closest to the source, the source of the traffic to be filtered. And if it is standard, places closest to the destination. So what are the factors that will influence the way where you are going to place your access list? The extent of the organization control. Placement of access can depend on whether or not the organization has control of both the source and destination network. That is what I just explained to you now. If I have access to all the routers, I'll go to router 3, create my access list there, and apply it on the interface that is closer to the destination. But what if I don't have access? There's nothing I can do. I have to work on router 1. Bandwidth of the network involved. It may be desirable to filter unwanted traffic at the source to prevent transmission of bandwidth consuming traffic. If I know that I want to block somebody at the destination, why will I burn my bandwidth? The packet will pass through for router 1, pass through router 2, pass through router 3, and then I'll go and block it in router 3. It will have consumed my bandwidth to go all the way. So I will create extended access list and come and block it at the source here. I don't need to go to destination because it's going to use my bandwidth travel. I know I will kill the packet. So why allow the packet to travel? Kill it from the source. Ease of configuration. It may be easier to implement ACL at the destination, but traffic will use bandwidth unnecessarily. An extended ACL could be used on each router where the traffic originated. So if I'm blocking people here, I can put one ACL here. If I'm blocking people on the other side, go and put another extended ACL there. This will save bandwidth by filtering the traffic at the source, but it will require creating extended access list on multiple routers. You want to save your bandwidth? You may have to do something like that. Interesting. I didn't know that's the last slide. Okay, so today's class, I told you, is going to be story. And that is just 1 hour's class. Thank you, Mr. Peter. So most of the time when I teach ACL, I teach it together. But for today's class, I don't have energy to teach the configuration. So I decided to just teach this theory. Then on Wednesday, I will teach the configuration so we can take our time and go through the configuration. Let me see the slide and see how many for the next chapter, see how many slides we have there. We have 41 slides. That's not small. "41 slides." And so next class is going to be lab all through. We're going to go through some of the slides. Look at access list for IPv4 configuration. So a lot of stuff to configure. We're going to configure IP version 4, ACL, how to secure line VTY with ACL. We're going to configure extended ACL. So we're going to take our time and configure ACL from beginning to the end. So let's try our best to come in time on Wednesday. And we'll try to do justice to access control list configuration. All right, guys, any question?